Hi, folks. We're going to take a look at page 391, number 12. So let's take a look here. We've got a cat that's sitting on top of a tree and sees a dog and a firefighter. Okay. Now, before I keep reading, and they're both on flat ground. So before I keep reading, what makes this problem a little difficult is that you're trying to represent a three-dimensional scenario in 2 dimensions. Okay, so we'll see how we can do that. So let's see what's happening here. So from the cat's point of view, the dog is 10 meters south, okay, at an angle of depression of 65, and the firefighter, they don't tell us the distance, but we know that firefighter is east of the tree. So first thing I notice is that south and east are perpendicular to each other. So we know we're going to end up with something right angled, and it gives us that angle depression. How far is the firefighter from the dog? Okay, so it's tough to really work on this question without having a diagram. Okay, so let's do that here. So first what I'll do is I'll have this line representing the tree. So there's the cat up there. Okay, and in the south direction, okay, so let's say I call this the south direction. So notice here I'm trying to create some perspective. Okay, so this is a line on the ground, 10 meters in the south direction. You have the dog, okay, and I can create a triangle. Okay, so this would be represent the distance from the cat to the dog. Dog on the ground, cat in the tree. Now what they give us though is they give us the angle of depression. So let's make sure we remember what the angle of depression is. So it's 65 degrees. So remember, this is not the angle of depression. Oops, sorry, I'm hiding that. This is not the angle of depression because this is the angle to the vertical. The angle of depression is going to be the angle from the horizontal. Okay, so notice how I'm drawing it at an angle, okay, same angle as that distance on the floor, to create this sense of perspective in 3D. So if this is 65 degrees, well, the angle that's actually in the triangle is going to be 90 minus 65, so 25 degrees. Okay, so now I've got a right angle triangle where I know a side length and an angle. So that's the good news. Okay, next we have the firefighter, which is somewhere east. Okay, again, right angled. So they tell me that the angle of depression from the cat towards the firefighter is, in this case here, it was 50 degrees. Okay, so if I draw a line to represent the view from the cat to the firefighter, this is the one that's 50 degrees, which means the angle inside the triangle is 90 minus 50, which is 40. All right, and now what they're looking for is the distance from the dog to the firefighter. So that's what we're trying to find. So one thing I notice in this second triangle is I do not have a side length. All right. So I guess in this triangle here, which again, remember, south and east is another right angle triangle, wouldn't it be nice to have this side length? All right, but I'm going to have to do this in 2 steps. So I'm going to have to use this left-hand triangle to help me find some information of this right-hand triangle. And usually when we do that, we look at what the triangles have in common, and this is the height of the cat. So the first thing I'm going to try to do is find the height of the cat, and I'm going to use this right angle triangle here. So here's my angle 25. I know the opposite side, which is 10, and I'm looking for its adjacent side, which is h. So I'm going to use tangent. So I have tangent of 25 degrees is equal to opposite 10 divided by adjacent h. And I can solve for this. So bring the h to the other side. So h 10, 25 equals 10. So h is equal to 10 over 10, 25. So let's calculate that here. All right, so 10 divided by 10, 25 is 21.45. Okay, let's keep 2 decimal places along the way. So now that I have this length here, I can now find this other one that I was looking for. So let's call that x. Okay, so now I can use the angle in the other triangle, tan of 40 is equal to the opposite, which is x, divided by the adjacent, which is the h value that I just found. So 21.45. So x is equal to 21.45 times tan 40. And let's do that. I think I still have the 21.45 there, so times 1040, and we end up with 17.994, so 17.99. So now I have that this is 17.99. Okay, and I think I have enough information to find the D value because this is a right angled triangle and I know two of the sides, so I can use Pythagoras to find the third. All right, so D squared is equal to 10 squared plus 17.99 squared, so D is equal to the square root of this whole thing. So let's calculate that. So we've got the square root of 10 squared plus 17.99 squared equals, looks like 20.6. And let's make sure, do they ask? So they don't specify how many decimal places here. So we'll just, we'll leave that as 20. Actually, we'll take two decimal places, 20.58, and everything was in meters. And so there we have it. All right, so to recap here, the first big step was getting this correct diagram. So a couple of important things is try to create this sense of perspective if it's 3D. So again, angle of depression is not the angle from the vertical, it's always the angle from the horizontal. So we had to find the complementary angle to get the one inside the triangle. Number two that was important to realize was that south and east were also going to be perpendicular to each other, which created that other right angle triangle. And then from there, use the information of one triangle to help you solve something from the other triangle. Okay, that's it for this one.